In this problem, which for my students is number 29 on the Unit 12 review, we're going to be calculating delta H, that is the change in enthalpy for the reaction C2H4 gas plus H2 gas yields C2H6 gas. We have three equations to work from. We have the combustion of C2H4 and its delta H, which would be its heat of combustion, and we have the combustion of C2H6. We also have the formation of water and its delta H, our heat of formation. Our goal is to rearrange these equations such that by canceling things that can cancel out, we end up with our final equation. I like to start by writing the final equation at the bottom, leaving myself some space to work. There are lots of different ways to go about deciding which equations to use at what point. I'm simply going to work from the top equation that I'm given in the problem down. In the top equation, I have C2H4. C2H4 is one of my reactants in my final equation. So I'm simply going to copy this equation down because C2H4 is already on the right side of the equation. I'm also going to bring down the delta H, the heat of combustion, which is negative 1,411 kilojoules. So now I've got 1 mole of C2H4 in my working area and 1 mole of C2H4 in my final equation. I'm ready to move on. Now I have an equation that is 2C2H6 plus 7O2 yields 4CO2 plus 6H2O. C2H6 is on the reactant side in this equation, but is a product in my final equation. So I'm simply going to flip this equation. And by flipping, we're simply going to take the reactants and put them on the product side, and vice versa. When we flip an equation in this way, we also have to change the sign on its delta H. So our negative 1560 will become positive 1560. So this equation will now be 4CO2 gas plus 6H2O liquid yields 2C2H6 gas plus 7O2 gas. And we're going to bring down our delta H with its now positive number of kilojoules. So now I have a small problem. I have 2 C2H6 in my working area, but only 1 mole of C2H6 in my final product. So what I'll need to do is to multiply each thing in my final product by 2, simply adding a coefficient of 2 to each of the different substances. Now my C2H6 matches up, but my C2H4 no longer does. So what I can do is come back to my combustion of C2H4 equation and also multiply that equation by a coefficient of 2. So I'll have 2C2H4 plus 6O2 yields 4CO2 plus 4H2O. When we add coefficients to the equation, we also have to multiply the delta H by that much. So when we have multiplied, we should get a negative 2822 kilojoules. Twice as many molecules, twice as much energy. So now I've got my 2C2H4 and my 2C2H6. All I've got left from my final equation is my 2H2. As I come down to the last equation in my working area, I see that it has 2H2 in it, and that the equation already has the 2H2 on the reactant side. So I simply carry it down. Since I didn't have to multiply this equation or flip it, I don't need to do anything to the delta H either. I can simply bring that value down as well. Now that I have all my equations in place, I need to cancel out anything that appears in my working equations but doesn't appear in my final goal equation. So my C2H4 should remain, but then I have this 6O2. So I've got 6O2 on the reactant side, and I need to cancel that out. So first I want to look on the reactant side and see if I have any more O2. And I find that I have a single molecule of O2 down here in this last equation. So on a grand total for my reactants, I have 7 O2 gas that does not appear in my final equation. So I need to see if I can find 7 O2 gas on the product side to cancel. And voila, there it is. So we can cancel our O2. Next, on this equation, I see that I have 4 CO2. There is no CO2 in my final equation, so I also need to look to see if I can cancel this. I check the product side and see that there are no other molecules of CO2 that I need to worry about. So I'm looking for 4 molecules of CO2 to appear on my reactant side. And here they are. So I'm able to cancel my CO2. Next I see that I have 4 H2O in my first equation, and there's no H2O in my final equation either. So I'm able to look for more H2O, and I find 2 H2O down here. So I have a grand total on the product side of 6 H2O. And here on the reactant side I have the H2O that can be canceled. So let's check. I have 2 C2H4, which matches up to my final equation. And I also have 2H2, and it matches up to my final equation, and there's nothing left on the reactant side, so I've canceled everything there. Looking at the product side, I have 2C2H6, and everything else has been canceled. So I have properly aligned my equations so that I can cancel everything that does not appear in the final equation, and my coefficients match up, so I know I have the right number of kilojoules with which to determine my final equation. We know that by adding the delta H's, we can find the change in enthalpy for our final reaction. So we put these numbers into our calculator and simply add them up. So we have negative 2822 plus 1560 plus a negative 285.8. And we should get a final delta H of negative 1547.8. One thing we need to check is, does our equation match the one we're actually looking for? What we want to know is, what is our delta H for C2H4 plus H2 yielding C2H6? But our delta H calculation is for 2CH2 plus 2H2 yields 2C2H6. So we need to divide everything by 2, which would leave us with C2H4 gas plus H2 gas yields C2H6 gas. Half as many molecules means half as much energy, so we also need to divide our delta H by 2. And when we do that, we get negative 773.9 kilojoules, and that is our final answer.